Hey everyone, and welcome back to The Explainer. Today we're diving into section 4.5 of Ian Sommerville's textbook on software engineering, and we're tackling a massive topic, requirements validation. Honestly, this is a pretty high-stakes area. Software engineering history is just completely littered with multi-million-dollar disasters that, frankly, could have been totally avoided. We always tend to think of software failures as coding bugs, right? Like a missed semicolon or a broken loop. But actually, the most expensive, catastrophic failures rarely happen in the code itself. They happen right here, at the very beginning, when we totally misunderstand what we're actually supposed to be building. So this explainer is all about how we stop those specific disasters before they even happen.
All right, let's take a quick look at the agenda for today. First up, we'll cover the introduction and error costs. Then, we'll get into the 5 requirements checks, followed by the 3 core validation techniques. After that, we'll look at the reality of validation. And finally, we'll wrap up with your lecture summary and exam focus.
Okay, let's jump straight into Section 1, Introduction and Error Costs.
So before we look at how to validate requirements, we really need to understand why we do it. We have to grasp the extreme financial and structural cost of errors that manage to slip past this phase. Take a look at our core definition here. Requirements validation is the process of checking that requirements actually define the system the customer really wants. Notice the heavy emphasis on really wants? We're not just spell checking here or making sure the formatting looks pretty. As the final critical check before we lock in the document, we are confirming that these abstract statements we've written down perfectly mirror the customer's true, actual operational needs.
To really put the gravity of this into perspective, just think back to your own varsity projects for a second. If you find a fundamental flaw in your system design before you've written a single line of Java, well, it's incredibly cheap and easy to fix, right? You literally just delete a sentence in a Word doc and rewrite it. Boom, done. But what if you only realize that fundamental error after the software program is fully built, coded, and pushed out to users? Yeah, that is an expensive disaster. You're looking at scrapping the code, redesigning the architecture, rewriting the whole program, and basically retesting absolutely everything from scratch. Requirements validation is basically our shield against that exact post-deployment nightmare. So just keep this in the back of your mind. Pre-code fixes are cheap. Post-deployment fixes are catastrophic.
Moving on to Section 2, the 5 requirements checks. Let's look at how we actually check these requirements.
And that brings us to the core technical framework of today's lecture. This is basically the exact criteria we use to interrogate our requirements document. Here's a high-level look at the 5 checks you'll need to know. We've got validity, consistency, completeness, realism, and verifiability. I want you to mentally map these out as we slow down and dive deep into what each of these terms actually means.
First up, validity checks. The core question you have to ask here is, does this actually reflect the real needs of the user? Now, I know that sounds super obvious, but remember, eliciting requirements takes a long time. By the time you finally sit down to validate the document, the actual circumstances of the business or the users themselves might have fundamentally changed since you first gathered those requirements. A valid requirement solves the user's problem today, not the problem they happened to have 6 months ago.
Second, we look at consistency. Are there contradictory constraints? The absolutely crucial point here is that requirements simply cannot conflict with one another. For example, imagine you're writing up a spec, and in Section 2, you demand heavy military-grade encryption for all data. Okay, great. But then in Section 4, you demand instant, sub-millisecond response times for your database queries. Well, if the available hardware cannot physically process that level of encryption in under a millisecond, your requirements are inconsistent. You just can't build a system that violates the laws of physics or hardware limits.
Number 3 is completeness. Are all functions and constraints included? So a completeness check is a really thorough review to confirm that absolutely every service, every function, and every operational constraint intended by the user is explicitly written down in the document. And guys, a very common mistake students make here is assuming a system will obviously do something, so they just kind of leave it out. Let me be totally clear on this. In software engineering, nothing, and I mean nothing, is obvious unless it is documented. If a stakeholder assumes the system will obviously do XYZ, but it's not written down, then your document is incomplete.
Fourth, we perform realism checks. Can this actually be built within the proposed budget and schedule? We really have to anchor our abstract ideas to the real world here. A requirement could be perfectly valid, perfectly consistent, and completely complete. But if it requires technology that doesn't literally exist yet, or if it would take 10 years and 50 million rand to build when you've only got 6 months and a tight budget, yeah, it's not realistic. We must always evaluate requirements against current technology, the available budget, and our strict timelines.
And finally, verifiability. Can we actually write a test for this?
I'd argue this is probably the most critical check for your future sanity as a developer. If a requirement cannot be objectively tested, I promise you it will inevitably lead to massive disputes between the customer and the contractor down the line. For instance, if you write a requirement that says the system shall be easy to use, well, that is not verifiable. How on earth do you objectively test easy? You can't. Instead, it has to be quantified, like a user shall be able to complete a transaction in under 3 clicks. See the difference? If you can't test it, it's not a valid requirement. So just to quickly recap our 5 checks: validity, consistency, completeness, realism, and verifiability. Now let's figure out how we actually perform them.
Section 3. 3 core validation techniques. Let's look at the how.
Okay, so we've established what we're checking for. Now let's shift gears to how we do it. Definitely take some notes here. The 3 core techniques are requirements reviews, prototyping, and test case generation. And each one of these serves a really unique purpose in flushing out those hidden errors.
Let's start with requirements reviews. This is a formal, systematic analysis where a whole team of reviewers, usually a mix of developers, customers, and domain experts, actually sit down and carefully read through the document. And they're actively hunting for anomalies, missing info, and inconsistencies. Because the document is being analyzed by multiple people with totally different perspectives, a business stakeholder might easily catch a validity error, while a lead engineer might spot a realism error.
Next up, prototyping. This involves building an early, executable model of the software system for end users to actually experiment with. Because let's face it, reading a highly technical document is super difficult for non-technical stakeholders. But if you hand them a visual prototype with actual buttons they can click, they instantly understand how the system is going to flow. This lets stakeholders see it in action, realize where their initial assumptions were maybe a bit off, and feedback crucial changes before the really heavy coding begins.
Our third technique is test case generation. This literally means devising the actual tests before you write a single line of software program code. It's an integral part of what we call test-driven development. If you sit down to write a test for a specific requirement and you suddenly find that it is completely impossible to design that test, well, that tells you immediately that the requirement itself is flawed or vague or unverifiable. It basically forces pure clarity. So, to recap those, we use formal reviews, executable prototypes, and test case generation to flush out the errors.
All right, Section 4, the reality of validation. Let's talk about human limitations.
Okay, let's pivot the tone just a little bit here. We've been talking a lot about theoretical perfection, right? But as engineers, we absolutely have to acknowledge the innate human difficulties and the sometimes messy realities of software engineering. This quote right here brilliantly illustrates the core problem, straight from Sommerville's text. Let's just read it together. Users need to picture the system in operation and imagine how that system would fit into their work. It is hard, even for skilled computer professionals, to perform this type of abstract analysis, and harder still for system users. We really have to acknowledge this reality. It is incredibly inherently difficult for everyday end users to mentally simulate a purely abstract system. And because of this human limitation, no validation process is ever going to be 100% perfect. Some requirements errors will inevitably slip through the cracks to the later stages of development. Our job is to minimize them as much as humanly possible, not pretend we can completely eliminate them.
And that brings us to Section 5, Lecture Summary and Exam Focus. Let's lock in those core takeaways.
So this brings our lecture to a close. Let's move into a very direct, highly structured recap so you know exactly what your exam focus is. For your upcoming tests and exams, you must be absolutely crystal clear on the following things. You need to be able to accurately define requirements validation. You must be able to list and define all 5 requirements checks. That's validity, consistency, completeness, realism, and verification. You must also be able to list and explain the 3 validation techniques: reviews, prototyping, and test case generation. Furthermore, and this is a strict requirement for your written submissions, you must ensure you use proper South African English spelling. So when you're writing your papers, ensure words like analyzed and realize are spelled with an S, not a Z. And please remember to use the spelling program with an MME at the end when you're referring to a computer program. Really, don't let silly spelling errors cost you easy marks.
To wrap things up, just remember that validation is the absolute final quality gate before the requirements document is finalized and the actual, wildly expensive system design and coding starts. We do all of this to save time, save money, and honestly, to save our own sanity. But as we just discussed, perfection is practically impossible. So I want to leave you with a bit of a provocative question to tee up our next syllabus topic. What happens when requirements inevitably change after the validation gate is already closed? How on earth do we manage that kind of chaos? Think about that for a bit.
and we will explore the answers in our next explainer on requirements change. See you then!